Hi, fifth graders. Welcome to Chapter 4. We're going to be beginning a division series now with our book, and we're going to be capitalizing on some of the same pattern techniques that we used with multiplication. So today we're going to be looking for fast facts, just like we did when we were working with multiplication patterns. We're going to use fast facts and powers of 10 to help us solve. So remember when we were working on fast facts with multiplication patterns, we would identify the fast fact, and then maybe count the number of tens involved and add the zeros to the back of the product. But with division, since it's the opposite operation of multiplication, we're going to count the power of tens and subtract them from their final quotient, the final result. So let's get started. We're going to look in number 1 here for our basic fast fact, which is 36 divided by 9. And in the beginning of our study, we actually went through and highlighted all of the fast facts. Basically, any digit that was greater than 1. So we're going to use that fast fact, 36 divided by 9, for all of these. You can use your multiplication charts that are in your math resource notebook. But for all of these, 36 divided by 9, you're going to be using that number 4 to start your result, okay? Now the only difference here is that I see a power of 10, 2 powers of 10, 3 powers of 10, 4 powers of 10 on the back of this dividend. I don't see any on the back of these. So there wouldn't be any additional zeros to add to this result. We would just have to carry these guys over. 2 from this one, 3 from this one, and 4 from this one. Now the difference comes in, I'm going to hop down to number 4 here, is when you have some zeros in the dividend and some zeros in the divisor. And that's when we're going to begin subtracting the zeros, or basically pairing them up against each other and removing them evenly. So in this first example, we just see 27 divided by 3, which we can look to our multiplication charts and know that is 9. So 9 is going to be the beginning of each of these results. This one doesn't have any additional powers of 10 on the divisor, so we just move the 3 zeros over. But on this one, we can see that the dividend contains 3 powers of 10, and the divisor contains 1 power of 10. So what that means, and it comes a little bit more clearly when you stack it up, is if we had 27,000 divided by 30, we would be doing the 27 divided by 3 part, making it 9. But then when we have an extra pair of 10 on the back, it's sort of like saying 10 times 10. So we can actually remove the 10 times 10 completely. And how many powers of 10 are remaining? We have 2 powers of 10 remaining. So it's like subtracting 3 zeros minus 1 zero makes 2 zeros. Following that same rule, we have 3 zeros minus 2 zeros. How many zeros would you have remaining if we struck through 2 sets of them? Yeah, you'd have 1 left. And if you take a look here, you have 3 and 3, which means you'd have no zeros remaining if you stack those up. Here, let's do that one. Over 3,000. Here's your fast fact, 27 divided by 3. And then these 3 sets would eliminate each other. And the reason that is because if you stretch this out into expanded form, you could think of it as 27 times 10 times 10 times 10, right? And you could think of the denominator here as 3 times 10 times 10 times 10. And we know that 10 divided by 10 is just 1. 10 divided by 10 is just 1. 10 divided by 10 is just 1. So really this entire block of 1,000 divided by 1,000 is just equivalent to 1. So 27 divided by 3 is 9, times 1 would still be 9. So it's like these terms eliminate each other, they cancel each other out. You might remember some of this background knowledge from when you were working with fractions and finding equivalent fractions and things that had the same result when you put them down into simplest form. Okay, let's take a look at number 2. Let's identify the fast fact. 28 divided by 7. I can see it inside of all of those examples. And what's the result of 28 divided by 7? If you're having trouble pulling up that fast fact, remember multiplication, division are exact opposites of each other. So if you can think of like a fact family, what times 7 would make 28? That's 4. Okay, so all of these are going to have 4 as their primary result, but then we're going to take a look at the powers of 10 involved. None here, none here. So nothing to add. 1 here, but none here. So 1 minus 0 is 1. 1, 0 to add. Nothing to strike against it or cancel it out with. 2 here, none here. Nothing to strike it out, so carry those 2 over. 3 here, none here. 4 here, none here. Okay, let's take a look at number 5 now. Here's your fast fact, 42 and 6. What's the fast fact that goes with 42 and 6? Yep, 6 times 7. So let's put the 7 at the beginning, and then go look for your powers of 10. 1 minus 0, just 1, 0. 2 minus 1, so we can even strike those out right there. You'd be left with 1. 3 minus 2, strike out 2 pairs of them, so you have 1 left over. 4 minus 3, so you'd be left with 1, 0 when you stack them up against each other. Okay. Number 3, why don't you pause the video, attempt it on your own, and then unpause to see how you did. Go ahead and do that right now. Okay. If you're joining me again, I'm highlighting my fast fact. And that's kind of a tricky one. 9 times what makes 54? Pull out your fast facts. It's going to be 9 times 6. So I know for all of these, I'm going to be using that factor of 6. And then I'm going to look to the powers of 10. 0 powers of 10, 0 powers of 10 means no powers of 10 to add. 1 minus 0 powers of 10, 1. There's 2. There's 3 to add. There's 4 to add. So anytime you have zeros in the dividend only and no zeros in the divisor, you're just going to transfer those zeros over to the result. You can see down below that these are structured differently. They're set up differently, more like long division, but you're still going to be encouraged to use fast facts first before you go into any kind of long division technique. So look for fast facts, and if you can swing it, let's do it. If you can't and you have to do long division, then we will. And I'll tell you today we aren't going to do any at all, but it's coming. So I know 6 times 6 makes 36. So I'm going to be placing the 6 directly above the 36 in the ones position, not in the tens position, because that would be like saying 6 times 6 is 3. And I don't want that. I want 6 times 6 is equivalent to this entire term, 36. And then I have nothing else to produce for this 0, so I just move it up into the quotient. All right, fast fact, do you see it here? What times 8 makes 72? Check your charts. 8 times 9 makes 72, so we have to put the 9 above the 2. And there's one more 0 to build it with. Now if you go kind of backwards and you think about what multiplication fact would complement it in its fact family, it'd be 90 times 8 is 720. Is that true? So 9 times 8 is 72, and an extra power of 10, which is 0. So we're right. Number 8 is 63 divided by 7, and that's going to be 9. But this time we have 2 powers of 10 on the back to bolster it with. Number 9, 2 divided by 18 is 9, directly over the 8 in the ones position. 2 powers of 10 to build it with. Okay, now on this next row, careful, look at, we've got a power of 10 in the divisor and a couple powers of 10 in the dividend. Now, do you remember what to do when you have some in the dividend and in the divisor? That's right. You have to eliminate one from each item in order to maintain equivalency, right? So if I remove a 0 from the dividend, then I'm going to remove 1 from the divisor. And that's like saying, remember, 10 divided by 10, taking away a 0 from both of those quantities does not change the value of the answer. We remember that this arrangement when we looked up at this one. 27,000 divided by 3,000 is still 9. We're just removing those extra zeros from the equation so that we can focus on the fast fact. We got rid of all of those extra powers of 10. So right here, we just got rid of one set of 10s. We have 1 left over, so we put our result, 5 times 5 is 25, plus the extra power of 10. Here's the fast fact. We're highlighting the non-zero digits. 6 times what makes 42? Oh, we had that one earlier. That's a 7. Now let's strike out pairs of powers of 10. Okay, so 7 is going to be the answer for that one. How about here? 8, and there's a 16. The fast fact would be 2 times 8 makes 16. I'm going to strike out powers of 10, and I have 2 extra to push up into the quotient. Here's a 2 and a 4. 2 times what makes 4? 4 divided by 2 makes 4. Strike out my powers of 10. And then let's count the rest of them and push them up as we go. 1, 2, 3, 4 extra for that problem. Okay, so for your homework, instead of using the workbook page, I thought I really wanted you to practice this type of skill a little bit more in a similar way. The back side of your homework page here, it doesn't quite follow this patterning practice that I'd wanted you to work on, so I made you a worksheet that has that same vibe, okay? So you're going to be looking for a pattern, highlighting the fast facts, and then using your powers of 10 to negotiate, do I add zeros, do I subtract them, and then here's some spots to put your answers on if you'd like, or if you're able to smush them right next to each of the problems, that's fine with me too. So really build on how we work together on the workbook. You're going to be recognizing the fast fact and then eliminating powers of 10s that are between the dividend and the divisor. The back is set up sort of like the bottom was, but you're still looking for fast facts first and then striking out pairs of powers of 10 between the dividend and the divisor, okay? We'll look through this patterning work a little bit more tomorrow, and if you have any other questions, remember Mrs. Doherty has math support today at 2 o'clock, all right? I'll see you guys later.